Distance off second bearing, practice problem 2. Here we go. Distance off second bearing, practice problem 2. First thing we do, we read the problem and extract all the information we need out of the problem. So it reads, your vessel is steaming on a course of 140 degrees true at 15 knots. It gave us a course. Course is equal to 140 degrees true. It gave us a speed. Our speed is equal to 15 knots. 15 knots, which is a nautical mile per hour. And it continues. At 1530, a lighthouse bears 200 degrees. So it gives us our first time and our first bearing. Time 1 equals 1530, 15 hours and 30 minutes. Bearing 1 equals 200 degrees true. And then it continues at 1550, it bears 249 degrees. So the same bearing at a time, our time 2, equals 1550, 15 hours, 50 minutes, and the bearing is at 249 degrees. Okay, and then it says, what is your distance off from the lighthouse at 1550? That's another way of saying, what is your distance at the second bearing? So it wants to know the distance off of your second bearing. How far were we away when we took that second bearing? And Bowditch has a table that's going to help you calculate this. In order to use that table, we need to calculate the change between course and bearing 1 and the change between course and bearing 2. Let's lay that out. So, change between course and bearing 1 equals the course minus bearing 1. What's the course? 140. 140 degrees minus bearing 1, 200. 200 degrees. What does that equal? Get our calculator on, clear. 140 minus 200 equals negative 60. Don't worry about the negative sign. We're just interested in the 60. 60 degrees equals the change between the course and bearing 1. Now we need to do it for bearing 2. So the change between the course and bearing 2 equals course minus bearing 2. Course, 140. Bearing 2, 249. 249 degrees. What's that? Get our calculator and say 140 minus 249 equals negative 109. Negative 109 degrees equals the change between the course and bearing 2. Now we can go to our table in Bowditch. Come up here with me close so you can see this. Okay, here's our table. And our first bearing, check out this. First bearing over here, 60. Second bearing, 109. First bearing is across the top, 60. And this first column, there's 2 columns. This first one is distance off second bearing. The second one is distance off a beam. So we're in this first column, distance off second bearing. And now down here in the left side, we're looking for 109. Okay, 110, 108, 110. So we're right between. We have to interpolate. So now we are on the row 110 and 60 right here. There's 2 numbers. You see that? It's 1.17 and 1.13. We need to record these 2 numbers and divide by 2. to interpolate this and get the average. So 1.17, 1.13. Let's write these down. 1.17, 1.17 plus 1.13. We add these together and divide them by 2. They call it interpolation. We're just finding an average. We're inserting a piece of information into this table that's not currently there. 1.17 plus 1.13 equals, divided by 2 equals 1.15. 1.15. Okay, this number from our table times the distance that we travel in this time equals our distance off the second bearing. So we say 1.15 times distance equals our distance off of the second bearing. Distance. How do we get distance? What is distance? Distance equals speed times time. We have a speed, don't we? 15. What about our time? We don't have like a direct time, but we have 2 times, and we can find the difference. So we can say we need to find the change in time, which is equal to time 2 minus time 1. Time 2, 15 hours and 50 minutes. 15 hours, 50 minutes. Time 1, 15:30. 15 hours and 30 minutes. So we 0 minus 0, 0, 5 minus 3 is 2, 15, 15, 20 minutes. Okay, we have 20 minutes, but to put it in here, we need it to be in hours. So 20 minutes times, or we're going to divide by 60. I just write it like this to keep my units straight. So in 1 hour, there's 60 minutes. Minutes cancel, you're left with hours. What's that equal? 20 divided by 60. 20 divided by 60 equals 0.3 repeating. We're going to go 3 decimal places out, so 0.333. 0.333 hours. This is our time, right? So now we can put this in for time. We can get our distance now. So distance is equal to speed, 15 nautical miles per hour, times time, 0.333 hours, 0.333 hours. Hours cancel, you're left with nautical miles, right? We're doing a distance. So 15 times 0.333 equals 4.995. Let's just leave it there. 4.995 nautical miles. Now we have our distance. So we need a distance to times by our table value, right? So now we can get the distance off. We can say 1.15 times the distance, which is 4.995 nautical miles, equals our distance off. 1.15 times 4.995 equals 5.744, and we're going to round to 1 decimal place, 5.7. 5.7 nautical miles off the second bearing. Let's check it out, see if we got it. I'm doing these problems with you. For some reason, this has it to 2 decimal places, but 5.75, that would be the closest one we got. Let's check it. and it checks out. 2 is C. That's the solution to distance off second bearing, practice problem 2, and we're going on to 3. So I'll see you there.